Hello everyone. Good morning, good afternoon, good evening to all. Dear authors and invited guests, welcome to Technical Session 3B. I, JL Alvani, moderator of this session. On behalf of Global Knowledge Trust Foundation, it is my great pleasure to welcome you to the first series of World Conference on the Information System for Business Management through Zoom. This series is organized in extension to ICD Project series. I hope you will enjoy the knowledgeable and interactive session through the day. There is a special note for the presenters. You will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10 minutes, I will leave a gentle reminder. There is another request to all that you all stay connected with us till the closing remarks. Just before we get started, if you have any query or update, you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session, Dr. Niranjan Day. Uh, Dr. Niranjan Day is an associate professor in the Department of Computer Science and Engineering, Techno International, Newtown, Kolkata, India. He is the visiting fellow of the University of Reading, UK. He is also a holder position of adjunct professor at Ton Duc Thang University, Ho Chi Minh City, Vietnam. Previously, he held an honorary position of visiting scientist at Global Biomedical Technologies, CA, USA. He was awarded his PhD from Jadavpur University in 2015. He is the editor-in-chief of the International Journal of Ambient Computing and Intelligence, IGI Global. He is the series co-editor of Pinzer Text and Nature-Inspired Computing Data Intensive Research series, co-editor of Advance in Ubiquitous Sensing Application for Healthcare. He is an associate editor of IET Image Processing and editorial board member of Complex and Intelligent Systems, Springer. He is the Indian ambassador of the International Federation of for Information Processing, Young ICT Group, and senior member of IEEE. Welcome, sir.
Yeah, thank you very much.
We have another chair, Professor Tanupriya Chaudhary. Uh, Professor Tanupriya Chaudhary has 10 years experience in teaching as well in research. Currently, he is working as associate professor of Department of CSE at UPES Dehradun. His area of interest include human computing, soft computing, cloud computing, and data mining, etc. He's a lifetime member of IETA, member of IEEE, and member of IET and other renowned technical societies. He is associated with the corporate and he is the technical advisor of Features of Private Limited Noida, IVR Guru, and My Digital 360, etc. He is holding the post of secretary in IETA, Indian Engineering Teachers Association India. He is also holding the advisor position in Indo UK Confederation of Science, Technology and Research Limited, London, UK, and International Association of Professional and Fellow Engineers, Delaware, USA. Welcome, sir. Let's start with the papers. Our first presenter is Hook Nguyen Trong, and his paper title is Combining Contrast Limited Adaptive Histogram Equalization and Canish Algorithm for the Problem of Counting Seeds on Rice. Dear presenter, you must start your presentation. Thank you.
Hello everybody. I'm Phúc.
Yes, you can start your presentation.
Yeah. Okay. You see my
Yes,
PowerPoint? Okay. Okay, we started. Hello, Mr. Mrs. Madam. My name is Phúc, and I'm from Vietnam. So in this presentation, I will introduce you the combination combining contract limited adaptive histogram equalization and candy algorithm for the problem of counting seed on right. And behind the scene, we will see farm in Vietnam. This is a gross I usually go when I go to university. And the table of content, we have 6 sessions. The first is introduction. The second is overview of research. The third is objective. The fourth is research scope and content. The fifth is approach. And the final is the result. So we move to the introduction. Counting the number of rices is essential in assessing the quality of rice variety such as yield, variety. For example, it is sloppy rice. Counting in the traditional way will take a lot of time and still have a certain error rate because of the human factor. So we will introduction. This research contribute to counting the number of bright rainbow particles by combining contrast limited adaptive histogram equalization and calendaricism on dataset of 1,050 right samples. This study results were evaluated by comparing counting by hand and by algorithm. The error result was 0.902%, in a little error. So the overview of research is there are many methods of counting an object on image. Counting the number of instances of object apart from 2 different aspects. The first is counting from the Jane's object detector. The second is Jane the object counter. And the study showed that the effectiveness of object counting algorithm with the right variable fast of affecting the quality of the objects and will affect the productivity from which the evaluation can be made quality, predicting the use of the respective object. However, no study has count the number of website ran per quarter. So we will do this research. For that reason, in this study, the research team count the number of bright grain by RGB color image recognition method and apply the candy contour injection technique under the condition that the light was still on the cotton in the laboratory. The research scope and the content. As you can see in the picture, there are 6 steps for counting. The first step, we have data collection. That means we collection data and collection from the Mekong Delta Rise Institute. The second is resize the image. The third is data labeling. That means we rename the image data, for example, grade 1, grade 2, or grade 3. The fourth image denotation, that means we enhance the quality of the image. The fifth is the image segmentation and color ejection, and the sixth is the quality result based on ejection result. And we move to the approach. First, we will do image denotation and enhancements. There are 5 steps. The first is convert image from RGB color to LAB colors. The second is separation of the image into different color channels. The third is contrast limit adaptive histogram equalization. And the fourth is combining CLAXE with AU channel enhancing stability with channel A and B. And the final is convert image from LAB color to RGB color and commit image enhancement in denotation. We will show this result right here. As you can see that image illustrating the process of image denotation enhancement from left to right, and we will see that it is L channel A, B, and it will be combined in channel, and the final is that the image with enhancement. That means the quality increase the quality. We move to the B, image segmentation and with cultural instructions. The first is convert image to grayscale, the second is flow image, the third is convert image to candy to reveal the culture, and finding culture count estimation, and culture approximation. And the final step, we will poke the photo raw finish counting the number of red grain. We will show the result. And you can see that this is a grayscale and this is the blur image. After that, we will apply the candy algorithm to the image. It is the algorithm. And the final step, we will pop the image. So this is the result we are counting. And to determine the algorithm, and we move to the results. To determine the algorithm Currently, we manually count 150 rice samples. The raw of each grain is determined by subjecting the grains of the corresponding sample count algorithm. In this presentation, we will show you the table of counting rice. When considering the algorithm results, it can be seen that the error based on the sample is quite high, about 20% to 25%. However, in general, the error based on the manual counting compared to the counting by algorithm is not much different. And we will see this in the table. The table one show that statistical result of the number sample and the error between hand counting and algorithm. You see the hand counting, we counting about 150 sample. They have the result 9,862 and algorithm counting is 9,773. The wrong number when we subtraction this is 89 and the wrong number of percent is 0.902. That's really little error. So we move to the new contribution of research, and the research has improved the algorithm compared to previous study, including improve the quality of the image before inclusion to determine the culture of the brains and adjust the color levels to show the image characteristic of the sample in more accurate counting. Elimination of aneurysm. However, there are some limitation of aneurysm. In calculating the number of culture, the aneurysm cannot clearly distinguish between the stem and the seed culture. As you can see, previous picture, a lot of pork is larger than the rice seeds, but in turn, generally on the last dataset, the aneurysm still give result with a low error rate. So this is all about the presentation of the paper. Thanks for watching.
Sir, you have any question?
Yeah, I have only one question. So, how can you find out the overlapping seeds?
Okay. You can hear me?
Overlapping. In the
Okay.
cases of overlapping, yeah.
Okay. So, uh, so as you can see the picture, uh, as you can listen, as you can see the picture, there are bigger pork in there are bigger pot to to poke the rice and the elimination of the representation so that uh, uh, the algorithm can can detect the overlap in the rices. So we encourage the later research to find this solution. Thank you.
Professor Tanupriya ji, you have question?
Yes, sir. Yes, sir. Nugent Trong, can you please define the accuracy of the system once again, which you have already explained the results? Can you please elaborate more?
Yeah, and we research the research is do with the elaboration and it do not do in the realistic because we using the data sample in the elaboration.
No, actually, I was asking about the basic accuracy of the system, where you have shown the statistical analysis. Can you please explain the accuracy in just a bit more? That was
Uh,
the question.
uh, Thank you your question. So can, can you ask again? I don't clearly your question. I don't listen clearly your question.
Okay, no issues. Good presentation indeed. Thank
Yes.
you very much.
Thank you.
Moving ahead on next presentation. Our next presenter is Masood Ahmad, and his paper title is Design of Smart Irrigation System in Stone Command Area Bihar for Paddy Crop. Dear presenter, you can start.
Very nice. Good afternoon to all of you. I am Professor Muhammad Masood Ahmed. I am professor in the Department of Civil Engineering at Maulana Azad College of Engineering and Technology, Patna, India. Today, my topic of presentation is that of design of smart irrigation system in the zone command area for paddy crops. As we are all knowing that India is basically, it is agriculture-based economy is going to exist here, and 70 to 80% of the population are basically involved into that activity. But still, majority of the agriculture processes are still monitored and controlled manually. Further, there is no well-established functional canal networks are available in majority of the area for supplying irrigation waters. Generally, farmers are basically dependent on that of the rainfall and that of the groundwater that they are basically utilizing through the bore wells. Also, agriculture consumes approximately 80% of the available water resources, and day by day demands of agriculture products are increasing because of population growth. This conventional systems that we are nowadays we are adopting not only causes large wastage of the water, but also requires the physical presence of the farmers in the field. Hence, there is an urgent need to develop new strategy which optimizes the water utilization as well as agriculture demands. So in this particular paper, we have basically tried to present a smart irrigation system that will solve a number of problems related to irrigation and agriculture of the paddy crops, such as saving of irrigation water energy, minimizing dependency on the rainfall and manual intervention, protecting the plants from disease, etc. Hence, the main intention of this study is to design and implement a smart system for paddy crop in zone command area Bihar using microcontroller-based Raspberry Pi 4. Now we have used this command area for that, which is very popular here in Bihar, that is known as that of zone command area, which is considered as that of the area of the rice bowl. Here, this particular area on the basis of that of the 50 years average rainfall, that is of that of the annual rainfall, is that of the 1100 mm. The soil is predominantly here is that of the clay loamy. The population density is that of 1068% per square kilometer as per the last census that has been done in India in 2011. And the major crop that is going to be grown in this particular area is that of the paddy crops. So, so for the entire focus for my developing this model is that of the paddy crop. Here in this paddy crop, we have basically using the microcontroller, we are using the sensors, we are using the solenoid valves for opening the gates, and we are going to have a ditch supply water. Then we are going to have a storage pond that we have created about into that of this. So in this entire system, we are basically using that of we are basically using the microcontroller board, different type of the sensor, relay, DC motor, and smart mobile app that we are basically using. So this system will use microcontroller to automate the process of the water pumping during both excess or deficit rainfall condition. Different sensors are used basically to measure the attributes such as the depth of the water in the paddy field, rainfall, and water level in the storage tank. The microcontroller also has an LCD to display the current status of the water level in the field. This automated system will always ensure the adequate required quantity of the water in the field, even though the farmers are away from the site. Particularly for that of the paddy crop is very sensitive with respect to that of water. So in this particular part, the adequate quantity of the water must be supplied at the right time. That is basically the crust for the maintaining the yield of the crop. In this particular system, we have also created a pond to collect the excess water during the heavy rainfall, and the same collected water can also be used to pump the field as and when water is required by the crops. This is basically the circuit model that we are going to use for that. This is basically a Raspberry Pi 4 microcontroller. We are going to have different type of the sensor, liquid level sensors. Then we are going to have relay modules for opening the valves and gates. in this particular part, basically Raspberry Pi 4 has been connected to the sensors, and sensor is basically connected to that of MCP 3008. This is basically connected to that of to convert the analog signal to that of the digital signal that Raspberry Pi basically recognizes about that or can easily read. Raspberry Pi 4 basically it is a flexible programming hardware platforms that control the circuit logically, in which automation process is designed by using the inbuilt library in Python programming language. This ETAB liquid level sensor basically measures the depth of the water in the field and as well as in the storage tank. Here we are fixing the threshold value for both minimum and maximum value, so that the motor operates automatically in on and off position as the water level in the field crosses the predefined threshold value. 4-channel relay module that we are going to use to control the opening and closing of the solenoid valves and the water pump. So Raspberry Pi, the microcontroller basically operates the entire systems. That is basically the things that are going to take place in this particular circuit. Now this is basically the entire flow chart that we have used. It before discussing about the flow chart, I am telling you about that of the general and agronomic conditions that are generally followed by the farmers in the zone command area for during the paddy crops. The duration of the crop that has been considered for is that of the 120 days, assuming that initial depth of the water available in the field is that of the nil. Bund height that we are going to provide for the field is that of 150 mm. At the transplanting date, we are supplying the water of 150 mm, including rainfall. From 1 to 44 day, we are checking every day at the beginning of the day that whether the depth of the water is less than 10 mm. If the water level is less than 10 mm, then we will supply the water up to 50 mm to keep the water in the field. That is to be maintained from 1 to 44 days. From 45, 46, and 47 days, all the water should be drained out for the efficient supply of the nutrient and effective control of weeds. On 48 day, again we will supply the 50 mm water in the field, and from 49 to 105, we will again check about that whether the depth of the water at the beginning of any day is less than 10 mm. If it is less than 10 mm, then we will supply the water of that of the 50 mm. From 106 to 120 days, no water is to be supplied in the field, as it is considered as that of the crop maturity period before harvesting. This entire for 120 days, this is the flow chart that has been created. That means that has been programmed into that of the microcontroller, and this is the condition that has been put into that of, so that the microcontroller operate according to the condition that is going to
sorry to
available.
interrupt, sir. You
Yeah.
can conclude your presentation, sir.
Okay, so so this is this entire database on the servers that will be provided on getting updated, and this entire information is to be supplied to the app. And this app is will look like that of this smart irrigation system app has been developed, and this app is basically the page will look like that. Then we are going to have this page will the farmer will enter their mobile number, and this mobile number will be verified through the OTP numbers. Once it has been done, then they will put their details about that of their name and the date of the cultivation. As they will put the date of cultivations from these calendars, then the entire process is going to be there automatically operates the things, and they are giving the informations to that app. So app on the farmer's mobile will fetch data from the server and will regularly inform the farmer water level in the field as well as in the pond, and status of the valves and the pump, whether it is open or closed, remind about the number of the remaining, so the farmers can monitor the field from his from using mobile apps directly here. So this is the conclusion that we are going to put it here. In this particular paper, we have put it in a smart irrigation system model for paddy crop in Soon Command Area, Bihar, India, is proposed and successfully implemented using Raspberry Pi microcontroller. This smart system automatically controls the entire activity once the farmer will register themselves through the Android app using OTP and entering the starting date of the cultivation. Farmer can monitor the status of water level and other operating conditions through the mobile app from any place. As far as concerned of that of the future scopes, a number of sensors can be added up in the field to supply the fertilizers, and fertilizers can be uniformly distributed, in the field. This is very much prevalent in the Israelis. So this sensor monitored fertilizer application is very, very helpful in the field if you are going to provide it. Further, multiple camera can also be put into the field to monitor the health of the crop through image processing techniques. If both these two has also been combined together, then I think this particular development of the paddy crop will be entire system will be automated, and we will get a very good result as far as concerned of that of the yield also. Hence, the proposed smart irrigation system will lead to overall prosperity to the farmers in the Soon Canal command area of the Bihar. This was the references that we have given it for that of these things. Thanks a lot for having a patience listening and giving me an opportunity for presenting my paper.
Masood sir, very good presentation indeed.
Yeah.
Actually, this said Dr. Tanupriya Chaudhary. I want to know the cost analysis of the system.
No, sir, cost analysis has not been done. This is basically implemented in our lab, water resources lab. We have tried to do the smart system in our just surrounding area. Farmers are growing basically the paddy crops, and they are totally dependent on that of this particular part. So this thought that we have taken it, this particular type of the model is basically used in the Nasik for growing the grapes that is transported, exported to the into that of France for making a very good quality of wine. So we thought about that. Can we do for also for the paddy crops? Because here the farmers are totally dependent.
Yes, sir.
On,
yes, sir.
on that
Thank you for your answer. But what is the basic cost of the sensor which you are using?
The sensor that we have used here, it is a very less cost. It is costing around per sensor. It is costing about 800 water liquid. But in the laboratory, in the field, we have to check it, sir. We have not done. We have not checked it anything in the field. We are taking a strip of the land from the farmers, and we are trying to implement this entire thing into the field, sir.
Okay. Thank you. Thank you.
Okay, sir. Thanks a lot, sir.
Nilanjan sir, you have any question?
No, I don't have any question.
So moving on, next presentation. Sindhuja M, and her paper title is Best Tensor Classification Model Using Principal Component Analysis and Deep Neural Network. Dear presenter, you can start your presentation. I think Sindhuja is absent, so we will move on next presentation. Lakshya Gupta, and his paper title is Music Genre Classification Using Federated Learning.
Right.
Yes, you can start your presentation. Thank you.
Okay. I'm audible, right?
Yes, yes.
All right, just give me a second. Is my screen visible?
Yes.
All right. So, hi everyone. My name is Lakshya Gupta. I am a final year student at Vellore Institute of Technology, and I'll be presenting the paper on music genre classification using federated learning today. So the music industry is facing a lot of privacy concerns these days. I think it's pretty evident in the news that we hear that so many privacy issues are going on in the industry, where so many people are using the music files in an unauthorized manner. So with machine learning branching out in almost every field, I think it's very easy to say that music industry is not an exception. There's so many third parties that are trying to reach out to music industries to analyze their data and interpret meaningful results. However, at present, it requires the industry to make all of their data available at a central location so that this third party can then process it and work on it, which is not something every industry would be comfortable with because it is an obvious breach of their confidentiality. Now, this was the driving factor for us to investigate some methodologies that could be adopted to provide privacy in machine learning collaborations for the music industry. So the hypothesis is basically to check whether there is any major difference in the accuracy of a decentralized machine learning model, basically a model that trains locally on every client device compared to a centralized, or you can say a traditional one, where all the data is collected in one location. So for this purpose, we picked music genre classification as the implementation, since it's relatively easy to set up. And our main crux is to find out whether when you're collaborating in a machine learning environment, when you're collaborating with audio files, is there any significant difference between these two approaches? So the problem statement is basically to feed audio files into a model, which is able to recognize features in that audio file and associate that particular file with a particular genre label. So coming to the methodology, this was the main crux of our approach that we followed, and this is basically federated learning. So federated learning is basically a machine learning algorithm that was proposed by Google in late 2016, relatively new. It basically provides a provision for decentralized training of machine learning algorithms. Subsequently, it helps the clients to retain their local data samples without transferring them to a central location. So if you look at the model on the right, you'll basically see that there's a global aggregation server, which is communicating with client devices, 3 client devices. So basically how it works is the model, every single client device is given the same global model, and all of them train that model on their individual data without revealing that data. And only the changes in the model, that is the updates to the model, are shared back to the global server, where a federated average algorithm is used to take an average of all the different client updates that have been received by the server. And that average change is then reflected in the global model. And that updated model is then again sent to the clients in the second round. And this keeps going on and on till we want the model to be trained. So that was the architecture that we basically incorporated. This was the most heavily used architecture, which was the like the new implementation that we are bringing to the table. Coming to the data set, we employed the GTZAN dataset in our project. And this is one of the most widely used data sets for music information retrieval. It basically has 10 unique genres. And to name a few, that's rock, hip hop, jazz, etc. So the original dataset consists of 1,000 music files, each lasting for about 30 seconds. Now you might think that 1,000 files is not a...
Lakshay, am I audible?
Yes.
Lakshay, actually your screen is not properly visible. It's stuck on the first slide. Yeah, now it's fine.
All right. Is it okay if I continue?
You may share it again.
Right,
You are
just
out
give me
from the
one
screen.
second. Just give me a second. Right, is it visible now? Hello.
Yes, visible.
Is my screen visible?
Yeah, please continue.
Yeah, thank you. So you might think 1,000 files is not a lot. So we basically split the 30-second file into 10 parts, each having 3 seconds of duration, which was enough to classify the genre of a particular music file. So this was the data set that we worked with. Coming to the process flowchart of our particular project. So again, just to reiterate, we started with a 30-second audio, split that into 10 3-second audios, converted that into a spectrogram. Spectrogram is basically an image which has all the features of a music file transferred into it using color codes. And then we used Google's TensorFlow framework to assist us with the federated implementation that we have proposed so far. Then since we were on a limited budget, we had assigned 9 clients to the TensorFlow dataset randomly. And then we splitted the dataset into training and testing based on client IDs. So 6 out of these 9 clients were used for training purposes, and the remaining 3 were used for testing purposes. And lastly, we fit the proposed model on 4 random training clients in each round. Now, why not all 6? Because that was done to avoid overfitting, so that the model doesn't learn to fit the data based on just one client's data if that particular client has a lot of data. So this is basically one sample distribution of the data among clients. So as you can see, every client has different amounts of data. And to make put it into perspective, client 2 and client 3, as you can see, the 6th genre, that there's a massive difference in the distribution of the number of training samples that they have. So coming to the results, so our proposed model got an accuracy of 80.2% in training, a 76% in testing. compared to a traditional model that's 92% training and 82% testing. So what do these figures mean? So as you can see, obviously the traditional model had a slight advantage with a 5% boosted accuracy compared to the proposed model. However, the purpose of this project, this research, was to investigate whether privacy could be enhanced in these machine learning collaborations. Because at present, a lot of industries who have a lot of data will not willingly collaborate with third-party industries. However, with the help of this implementation, even though there's a very slight reduction in accuracy, it makes the project of collaborations more industrially feasible from a business aspect, because companies can actually ensure that their data is protected, it's not leaked. So that makes this project more industrially viable. Now, coming to the discussion, obviously there were some shortcomings that could be improved upon in the future. So the very first, as I had previously mentioned, we were working with a constrained budget. We did not have the resources to carry this out on a large scale. So we basically had simulated this entire setup on a single device setup. So because it was carried out on a single system, it took a heavy toll on the RAM, and obviously the computation was not the greatest. However, in actual production, federated learning is supposed to be integrated with separate devices. So carrying out the training on different systems could have yielded better and probably more realistic results for federated learning. And lastly, the issue that I initially communicated, wherein every client has a different distribution and different type of data in a federated environment. So that's usually called the non-IID data type issue. So FutureWorks can modify the aggregate function, wherein reinforcement learning can be used to obtain a fairer contribution from each client instead of taking an average of the updates. And that brings me to the conclusion. The conclusion is basically that we have made a federated learning, we have made an algorithm, a model that is basically classifying music genre of a particular music file without the need of that client to send that data to any central location. And to minimize overfitting and to imitate an actual federated environment, a variety of clients were used. The findings show that if in a federated environment, all the client devices have significant amounts of data, federated learning may produce global models that perform quite similarly to centrally trained models, the traditional models. And lastly, this has the obvious benefit of user privacy and storage cost reduction, because there is no cloud needed for storing all the data. So that again reduces costs, and it makes this more usable from an industrial feasibility aspect. And with the advantage of privacy protection, I believe this technique could be transferred not only from in the music industry, but to any other industry that holds importance for its confidential data. So thank you. Thanks for having me in this conference. I open the floor for any questions.
Lakshay, thank you. Lakshay, can you please come to your dataset? Lakshay, am I audible?
Yes, I can hear you.
Yeah, can you please come to your dataset?
Sure thing. Yes.
Actually, the dataset is not visible here.
It's not. Okay.
Yeah, it's fine.
Okay.
How many attributes are there actually? How many classes and all?
Right. So basically, the data set, it doesn't have classes because it's not your traditional classification project wherein you usually have different features for different items. You only have a music file. That's it. It's a collection of music MP3 files. So it has 1,000 MP3 files which are stored in the dataset. No features, only the music files. That is, we convert that into images. We convert that into spectrograms, which is then worked upon for classification purposes.
Okay, and how many hidden layers are actually there in your model?
Right. So I think I skipped this one. This is the CNN architecture that we used. So we have 4 convolutional layers that we used, and this was decided using hypertuning. There are no hidden layers as such because the convolution layer itself were able to pick up all the features. We did have a flattened layer so that all those
that's why I asked you. I think you have missed this slide. No issues. Very good presentation you have done indeed. But one point for your information,
Yeah.
In future, if you're presenting any paper in a conference, try to make the PPTs in an aligned mode, as because the justification is not proper in the slides only, not in the terms of research and not in the terms of quality. Quality is perfect,
Right.
but where you are using the informations, like you can come any slide, like
Right.
methodology, you can come, yeah, in the
Yeah.
above one, yeah, before, yeah, this slide. If you can select your text, and then if you can click on the justification tab in just
Right.
below the view, then it will look better. Don't take it
Right.
otherwise. It's a very good PPT you have done.
Noted, sir. Thank you so much.
Thank you. Thank you. Good.
Thank you.
Okay. Over to moderator, please. Thank you.
Thank you so much for your nice presentation. Our next presenter is D. Buji Babu, and his paper title is Keyword-Based Global Search to Understand the Impact of the Scenario of the Keyword. Dear presenter, you can start your presentation.
Yeah, actually, I request if within the time slot the presentation will be done.
The time slot is 3 p.m.
No,
So
time slot
the
means per presentation. What is the total minutes dedicated?
15 minutes, sir. 12 minutes for presentation and 3 minutes for question and answer.
Okay, okay, fine. Thank you. When it will be 10 minutes, please inform them.
Yes, sir.
Thank you.
I think he is absent. Just a minute.
We can skip him, then we can come to the next presentation, please.
Yes, we can go on next presenter. Kiran A, and his paper title is Synthetic Data and its Evolution Metrics for Machine Learning. I think he is also absent. I invite Siddhant Singh. He is from last session. So he's going to present on GN to produce new faces and detection expression. Siddhant Singh.
Yes, sir.
Yes, you can start your presentation.
Okay, thank you. Okay, so is my screen visible?
Yes, sir.
Okay, so is it in full screen mode now?
Yes, you can start.
Okay, so good afternoon to one and all present here. Today, myself Siddhant Singh, and we are here to present our paper, GAN to produce new faces and detect expression. So our paper ID is 102. So we will be going forward with introduction, problem definition, then objective and the outline, and then the possible methodology for this, and then we will get on to the result and conclusion. So first of all, many of us might be new to this field like machine learning, and many of us know this field machine learning. So GAN, the full form of GAN is generative adversarial network. Basically it is a new technology introduced in 2014 that is being widely used, and it is a broad field to encounter more and more. So let's move on to the problem definition. As I said, GAN was introduced in 2014, and it is a modern technology that can generate new things from the given data. Our study has two phases. In the first phase, we will generate new faces from a data set, and then we will detect the expression of the generated face from the GAN model. So we have gathered the data set, and we have pre-processed all the images in the data set, and then we have generated a discriminator and generator model and trained it, and then a model is created to detect the expression. So the outline of our study is that the dataset was gathered and the images that were suitable for training purpose, it was filtered out from that dataset. Then a discriminator and a generator model was created and it was trained successfully. After that, a expression detection model was created and the faces were and the and the expression were detected from of the generated faces. So here it is an overview. First of all, the data set will be given and it will be pre-processed. Oh, sorry, it will be pre-processed. Then the training of the generator will happen and the images will be generated. After that, facial detection will be done, post which we will detect the expression of the face. So basically, this is a simple display of the GAN model. Let's come to the real world. To explain this, I will use a real world example. Most of us might have seen the MasterChef TV reality show, right? So we can assume that I am the generator model, I am a participant, and the judges in the MasterChef are is a discriminator. I am the generator model, I am generating new food from the ingredients available, and then the MasterChef is judging on the quality of the food, right? So same here, the generator generates images from the data set and the discriminator discriminates the real image and the generated image. And if the quality is good, then it is passed on forward, and if it is not that much great, then it is known as a loss. So after the image is generated, the facial features will be extracted for expression detection. The region of interest, ROI, is fed into the model trained for the expression detection, and the expression is being detected. So here we come to the result. Here you can see that these are the images generated from the dataset. One point to be noted that these are the newly generated images or faces. These are not present in the real world or in the data set. It is a newly generated face, we can say. And here you can see the progress of a generator model with each epoch. After each epoch, it is getting better and better. So now after the image generation, the expression will be detected. We have used 5 parameters for expression detection. That is A is for angry, F is for frightful, H is for happy, N is for neutral, and S is for sad. And all the percentage are added here. The more the expression having the the parameter having the highest expression will be declared as the final expression of this face. So like here it is the angry A has the highest percentage of 62%. So we can say, as per the model generation and training, this is an angry face. So now the future scope of this field, as I informed that this is still a field to be broadly studied. This the many researches and studies are still going on. We can explore this field very vastly, and then for a better image or a better data set with proper image can be used in the data set to generate faces. So we have generated some human faces from the dataset which are totally new in the world, and also we have detected the expression of the faces so generated. Okay, so at last, one point I will like to mention that what are the applications of this technology, right? So IB and CIA, Intelligence Bureau, CIA, and all the special agencies are using this GAN technology to identify face or to get some results according to their problem. Like CIA has introduced this technology into their system in 2019. So that's all for today. Any questions are welcome here.
I am having just one question. Why actually you have used GAN?
Okay, so basically, sir, as I said, GAN, generative adversarial network, it is a very deep and broadly field to be explored. Okay, so we were trying to explore some new field, and now we have used GAN because it generates totally new faces. We also know different models like different supervised machine learning models. In that case, those models do the job of either classification or some type of recognition. But here GAN, it totally generates new face from the face given. Like the faces generated, you will not find any face exactly to that in the database. It is totally creating the face from the scratch.
And is there any comparison analysis you have done?
Okay. So, sir, as I said, the job of the discriminator model is to compare the quality, the realness of the image generated to along with sorry, it is the job of the discriminator is to compare the realness and quality of the image generated with the real image. So the comparison is being done in that model only, the discriminator model.
Okay, okay, sir. Okay. Thank you. Thank you for a nice presentation, sir. Thank you.
Presentation. And at the last, we have one presenter, Shama, and her paper title is Optical Wireless Communication for 6G Networks. Are you there?
Yes, hello everyone.
Yes,
so
you can start.
yeah, I'll just share my screen. I hope my screen is visible. Hello everyone. My topic is optical wireless communication for 6G network. My name is Shama and I'm a research scholar at BMS Institute of Technology, Bangalore. So coming to the introduction, the chapter introduces, it's a book chapter, so it introduces the radio frequency, role of optical wireless communication for deployment of 6G, terahertz communication, visible light communication, free space optical communication, ultraviolet communication, and then highlights and highlights of the application and limitations. Speaking about the background, giving you a very little information and the gist of how it works. The most important aspect of the current situation is technology, the communication technology. So without communication, I guess it's very difficult to run our lives in this era. So wireless communication started, I'll be talking more about how the wireless communication started. It started in the year 1981, where 1G was just came up during that era, and further till 5G. I feel 6G will be the booming communication network, which will be well established by 2030. And the servicing offered by the 5G are quite humongous, just like ultra reliable, low latency communication, and additionally reliability and massive network capacity, improvised and increased availability, massive machine type communication. These are some of the high multi GBPS. These are some of the services offered by the 5G, including high multi Gbps data speeds. So coming to the next point, with the blooming development and increased commercialization of 5G, it is right time to expand to further 6G. So hence we did a little research and came up with this little information about the 6G and how it works in the future. A tentative timeline has been drafted for the implementation of 5G, B5G, and 6G respectively, according to the international standardized bodies. The reveal of a 6G will take the storm, take the world into the storm by 2030 is the prediction. It's going to change a lot in the communication technology area. And coming back to the and multiple multiple applications of the 6G are noted below. I'll move to the next. Radio frequency. This is one of the basic technology which has been implemented when the 1G was started. That is Wi-Fi. Under radio frequency, Wi-Fi is the most used form of wireless communication connection across the world, which is satisfied by the radio frequency. Radio frequency provides a range about 3 kilohertz to 10 gigahertz. This only supports some of the small amount of optical wireless communication, but it doesn't support all kinds of communication right now, which is existing. Hence, the research which goes about the limit, that is 60. So after some of the discovery of mobile phones during the 1979 before 1982, where 1G came into picture, the mobile phones came before that. The radio frequency was also used as the main communication network for verbal exchange. So some of the limitations for 60 networks are in the next slides. Okay, so radio frequency, the structure of radio frequency, as you can see in the image, the source right from the source, there is a transmitter which communicates the data, and then there is a medium, and then a receiver and the sink which cools the data. Cools the system, which is again the RF is classified into both the terrestrial and space-based system. Terrestrial system is composed of WLAN, which is point-to-point, and space-based system is again line of sight communications. Terrestrial system is a line of sight communication. Space-based system, again, the communication between the satellites is done through uplink and downlink with the data transfer. The system mainly constitute of like the image which I explained earlier, that is transmitter channel and the receiver. Moving back to the next slide, security issues and challenges. There are multiple challenges under radio frequency, hence we are moving back to terahertz communication. So let me inform about security issues under the RF. The theft of data is quite common in radio frequency. The hacking is quite easy in the radio frequency, which allows the hacker to access the code and also the data, and the malicious entry is quite common here. Hence, RF is not recommended, and the upcoming and other technologies has been proven better than RF. As you can also see that the omission of mistakes leads to attenuation and low frequency. Yes, there is a data attenuation, and there is a low efficiency in radio frequency. There is a poor, in case if there is a poor infrastructural, meaning it can only work for a very small area and not to the bigger area. And there is a lot of active attacks which can happen to the same. And there are some of the reasons for RF not used as a technology for 60, as we are talking only about the 60. It breaches the security and privacy. It is a very short range and frequency. It doesn't support complexity of the newly advanced electronic gadgets. It can support transferring high rate of data transfer. It cannot support transferring of high rate of data transmission. Moving to the terahertz communication, it's the closest required frequency range, which is provided by the terahertz to support 60 networks. Terahertz is the substitute name of the spectrum range that falls into the category of 0.1 to 10 terahertz. The frequency can penetrate through a lot of materials with a minor attenuation, making it a very feasible one to the opaque objects. So it penetrates through the opaque object, which makes it again not very secure. So again, there would be challenges with the terahertz communication as well. So and some of the application of the terahertz WLAN system include Tera IoT, Tera Spacecom, Tera Wi-Fi. The limitation include low antenna gains at the receiver end. Given its high frequencies and attenuation, it may lead to the gain reduction. Again, the gain frequency would be reduced here. Gain value will be reduced. The power consumption of the devices using terahertz is going to be challenging, yes, of course. And the few more challenges include link stability. The connection between point-to-point stability would be very low, and the beam pointing control is also low. And moving to the terahertz channel, the terahertz system consists of a transmitter, channel, receiver. Given this aspect, the propagation characteristics are modeled between the transmitter and the receiver. The atmosphere plays an important role in the absorption of the frequency, and it cannot be neglected like that of the RF. The scattering effect of the terahertz is a major concern. There is another loss which is arising in worries, that is the spreading loss. The beam is not very focused and it is not very efficient as it spreads across, and there is a loss of the energy there. Hence, it is again one of the drawbacks of terahertz. Weather also influences to the attenuation of the terahertz. Terahertz communication is used in system-wide channel sounding and implemented using channel impulse response, that is CIR, as you can see. Coming back to how it works, application and challenges in 6G network using terahertz. Here, UMMO, that is ultramassive multiple input, multiple output antenna system, is one of the applications. Medium access control is again very well versed here, and modulation and coding is also achieved using terahertz. The challenging part, again, talking about challenging of terahertz, again, there are more of challenging I can address here in terahertz. The attenuation is greater due to the frequency inference. The total range of the frequency has proven it can add up to the requirement of the 6G communication. It has a lack of coding applications. And then the appliances are moving from 5G to 6G, which is not very economical, which goes expensive. Hence, terahertz communication might not be an ideal option to be used in communication field, communication technology. Okay, coming to the visible light communication, VLCs here, directly I'm talking about the limitation of this. It has a limitation of RF, which can be overcome by the VLC, that is transmission speed, transmission medium, penetration through walls, that is the security breach, and then interface from other electronic devices disrupts the frequency. So what I'm trying to say is VLC is doing better than radio frequency. The VLC offers unlimited bandwidth, and the solid state lighting has been the main reason for the development and deployment of VLC communication. Communication is mainly based on the visible light region. Either we use visible light or we use RGB lights. It's the choice to make between these two approaches. And visible light communication. So there are two types here again, indoor visible light and outdoor visible light communication system. With this increase in electronic devices usage per specific area, it is more convenient to use the indoor VLC, as the devices used per person on an average has increased to 2 or more folds. And explaining about the indoor visible light communication, as you can see, the data as a modulator which modulates the light resource and reaches the device, and then the photo detector has been identified and it demodulates, and then the data comes out. That is again coding and encoding happens during this penetration. Coming to the challenges, the LEDs, that is LEDs can be shifted from one to another. It leads to the loss of data and connection. LEDs have very low bandwidth
Dear
modulation.
presenter, sorry for
Yes.
interrupt. You have last 1 minute.
Okay, thank you. Noise that is added and inferred from other light sources causes decrease in efficiency of the VLC. The multi-part diversion of the scattering effect of the light causes delay in transferring the signal, and setting up light units of direct path leads to decrease in the feasibility. The increased exposure of LED light has a drastic impact on the human eye. Hence, LED is multiple challenges which is not advisable to take up in the communication technology. The free space optical communication, the FSO, uses an open space such as vacuum and air for indoor and outdoor. For indoor optical wireless communication, and for outdoor it's called outdoor optical wireless communication. So the signal is a form of light transferred through the air medium. Coming back to the limitations here, the range of signal still stays insufficient and it has to be extended. The loss is high, and the security issues are quite a lot, and single beam causes a lot of attenuation, but we are trying to get a single beam to achieve the 60 or achieve any good communication. A single beam has to work thoroughly, but here, as you can see, attenuation, we don't recommend FSO. And then coming to the ultraviolet, as you can see, I'm running out of time. I feel ultraviolet has an application and challenges. And this is the summary made. And in this summary, we are trying to explain that how ultraviolet communication is much better than FSO, visible light, terahertz, and radio frequency. Hence, I'll go back to ultraviolet and explain why applications of ultraviolet. So UV communication is highly secure, and so that both the civil and defense purposes and the penetration of this laser beam is has been challenging in other kind of communication, unlike ultraviolet. So UFA is also used in aircraft landing under the low visibility conditions. Hence, ultraviolet is much better than RF and other kinds of communication. So these are some of the challenges. And to conclude, I would say that further development of terahertz is to make it available in terms of inexpensive small laser diode, as it is considered as very expensive and not efficient right now, and not reachable to multiple people so far. Hence, it has been hence the research has been going through to cut down on the expenses and make it reachable to more people. Using such kind of detectors which can observe well are also used to enhance its transmission. So yeah, the overall data rate expansion for the VLC is done by techniques such as orthogonal frequency division multiplexing, discrete multitone modulation, and multiple input multiple output, and wavelength division multiplexing, and so on. So hence these are all data rate expansion methods are advisable to work on. The performance of FSO can be improved by implementation. Earlier, I said that FSO is not very much suitable, but yes, performance of FSO can also be worked on to implement for this technology. And SSE OCDMA can be further used, and the data rate is increased further by low pass filter. UVC can be further developed to implement UV BLED. Which will provide extraordinary data rate using QAM. So these QAM meaning the quadritude amplitude modulation. So these enhancements are likely to be done, I mean, by 2030 to improvise and launch 16 networks. And these are some of the references. And thank you, and open for the questions.
Thank you, ma'am, for a nice presentation indeed, but I'm not from a communication background. So sorry, no
okay.
question from my side.
All right, so thank you.
Thank you.
Thank you so much for the nice presentation.
Thank you,
we
sir.
have
Yeah.
Dr. D. Buji Babu, and his paper title is Keyword-Based Global Search to Understand the Impact of the Scenario of the Keyword. Dear presenter, you can start the presentation. Thank you.
Yeah, good afternoon to you all. It's my pleasure to present my scholars, my students' work carried out in the field of data engineering. So I'm going to present my research title, Keyword-Based Global Scenarios, to understand the impact of the search of the keyword. See, this is the carried out by my students, MCA PG students. They carried out this work. So this is the contents of this work. In the initially, we are having abstract of the work, and introduction of the work, literature survey, methodology, implementation, results, and conclusion. See, in brief, if you come to the abstract of the work, nowadays the entire world becoming a village because of the globalization. The role of globalization is playing a vital role, and all the information and whatever all the things are available at one place because of due to e-marketing, due to so many online platforms, so many things are came into the picture. Therefore, it's easy to identify and it is easy to analyze the things what is happening in and around the world. See, particularly if we concentrate on the Google Trends, nowadays, everywhere, whatever we do, all these things are being captured. Suppose you take an example of we visited a particular restaurant. Okay, immediately the AI-based devices are going to capturing the location and is asking the feedback about that. See, that is the role and there is a trending is going on nowadays. So in this paper, my students are mainly focused on the keyword-based search, and they focused on how the searching is going to happen in the Google search, as well as why not we conduct a search about the different kinds of data sets using different techniques like long and short-term memories and feed-forward neural networks. They are used in very advanced techniques and multilinear regression and elastic net model. Okay, they used different kinds of techniques and they took some 20 countries data as a unit, and they executed the code in the Python programming language, and finally they analyzed throughout the 20 countries. So this is a brief work carried out by my students. Okay, see, come to introduction part. Google search engine, I need not to explain more about the Google search engine because of whenever we are having any kind of things, clarifications, we are approaching the Google search engine. See, because of it is providing exact information, it is providing the relevant web pages after searching, because it is doing a lot of searching, lot of filters are being filtered over the internet. Nowadays, only one solution, Google Trends, capturing a lot of information. Okay, and it is providing the services with free of cost because of they are not going to charging anything. So even in sometimes the Google Trends is providing some official data also immediately. So in this paper, our scholars used various types of data sets and they executed the queries through the Google Trends around 20 countries, and the search results were captured and were presented in this presentation. See, search engine provides users to search results with relevant information that are available on high quality websites. What is the main problem in the toggle based search or in the keyword based search, okay, or in the web mining or whatever is the mining? Okay, the main problem we are facing with a lot of retrievals are coming. So it's very tough to us to identify which is relevant to my query. So that is the main question. So the quality of the search and the outcome of the search is depends on the relevancy. So if your outcome is more relevant, then only we can say that a particular query is searching, that particular search engine is providing a qualitative information. So Google search is a famous tool for explore the data because of it is free of cost and easy to access and is providing potential to predict the data immediately using the Google Trends data. So this is a brief introduction to about the search engine concepts. And coming to the literature survey, my students have performed a lot of scholarly articles and standard journals and IEEE publications. And finally, they are focusing a lot of issues on privacy and security. Because of nowadays, the data size is going to doubling. Okay, it's when the data size is going doubled, multiplied, automatically the hackers are there, so security and privacy issues will come into the picture. So it is a big challenge to overcome the privacy and security issues. Sometimes the browsers has been the subject of the substantial literature. Okay, this can be broadly categorized into three main concepts. See, online tracking by the websites, and second one is attacks against the browser itself. Third one is phishing attacks, which we are having, we are facing the frequently. Just nowadays, you take any kinds of banks frauds. Okay, almost whatever is the number of complaints received by the bank managers are majorly these kinds of phishing attacks, these kinds of online frauds. Because of now the security is need to be strengthened a lot. So finally, our students, my scholars, are identified these number of problems. So these are all going to be addressed, okay, in various stages, as they are taking each one as an objective of their problem statement. Okay, and the Google Trend is a popular target exploring search engine because of the data. So our research is focusing on the search results. Particularly, we are not using any kind of all those things, but our work is mainly used a concept called Python programming. Okay, they used some queries. Okay, they used the methods like this. See, during the work, we used the seasonal ARIMA with the external regression mechanism, and multiple linear regression mechanism we applied, and elastic net concepts we used, and support vector machine regression we used, and standardly feed forward neural networks. Because of so many things are going to be used, and different types of layers are there, different types of databases are there, data modes are there. So to search in all the parts from root to bottom, okay, they use the feed forward neural network, and also long short term memory is also used inside this. So these are all the methods used to carry out the work. Coming to the methods, seasonal ARIMA without external regression. That means both the cases they tested with regression and without external regression. See, in this multiple linear regression can be computed with response variable predictors by multiple regression. It is an extension of linear regression which is used only one explanatory variable. So in the area of econometrics, the financial influence, we use MLR. MLR formula is like this: yi equal to beta naught plus beta 1 xil plus beta xi2, like that. Okay, beta p xip, where n observations per I value and dependent variable vi and exploratory variable called xi. Y intercept is beta naught. Each slope coefficient variable is beta p. So model's error returns the e. And you come to the elastic net. Simply we say this is a EN. It is a regularized regression method. It combines L1 and L2 penalty functions. Based on the sum of the squared coefficient values, one penalty is penalized. It is L2 penalty. L2 prevent the coefficient that are removed from the model.
Dear presenter, sorry for the interruption. Your last 2 minutes.
Yeah. I'm going down. Yes, see, this is the elastic net we are using, and the next one we are going to use support vector mission. It is used to predict the discrete values, it works as similar to support vector mission principle. Okay, finding the best fit in the main objective of SVR. I think all we are aware what about the best fit and worst fit. Okay, in the best fit, whatever the data is fit for our regression model, it can be treated as best fit. So the SVR is the best fit line that has the maximum number of points. Y equal to Wx plus speed. It is the hyperline. So, and one more technique we are using, the technique is feed forward neural network is also used in this. Okay, see the approximation function in the feed forward neural networks, the main and important thing is the approximation function. Y equal to f into function of x. It is the formula to classify assigns x to y. So FFN will map y equal to f of x comma theta. Will memorize which is appropriate function. And the last one is long short-term memory. In artificial intelligence or in any kind of deep learning mechanism, okay, the technique is used. In AI and deep learning areas, we use this artificial neural network method, that is LSTM. It is based on the short-term memory process to create longer-term memory. LSTMs are the complex of deep learning mechanism. So our we executed the entire system using Windows.
Sir, sorry for interruption. Can you please directly come to your results so that rather than implementation basics, we can see your results?
Okay. See, this is the keyword we taken. Okay, the keyword is we took a term called analytics. Okay, in the Google searches, the analytics were identified in different areas. Almost the keyword was searched in 20 countries. See, all these are the different types of searching outcomes. The keyword is the analytics. Okay, the analytics outcome is placed. These number of times the keyword is placed. The outcome is placed. Suppose in the 2018, the analytics term was searched 30 plus times, and 2009 is the count. So this is the keyword based search impact, and this is the date by the date dimension and getting the sum of the clicks. So the same keyword, analytics keyword is there. Okay, day wise, how many people are searching. Okay, that kind of outcome is this one. And finally, the results is exactly showing over a period of 5 years. Okay, it is stayed pretty stable with the highest peak around 2020 because of their more number of searches are there. This is the total conclusion. So totally, what is our work is the methodology developed for this research will be tested in the areas of other than the real estate in the market. That means you can consider the Twitter data, Reddit data. So from various sources, you can gather that information. All that information can be searched. So it's giving some solution for the real estates and all. So finally, I acknowledge to all the others and co-authors to help me to complete this work. And these are all the references. I thank to all the others, okay, those who provided the literature survey for us, okay, to complete this work. Thank you, sir. Thank you very much. If any questions, please.
Thank you, sir. Thank you for a nice presentation. Can you please explain the data set which you actually have used?
Yeah, there is no data set. Actually, the thing is, that is the beauty of this project. Okay, we are going through the Google Trends. So automatically the AI based algorithms are utilizing, that is, we are mentioning the list of countries. We are mentioning 20 countries as a data set we are taking. In the 20 countries, the machine is going to be searching for the analytics. Here now we are not using any kind of traditional data sets. We are not using.
Then how you are giving the input?
What, sir?
How you are giving the input?
Yeah, input we are giving only in the Python query only. Okay, in the Python, we are writing the queries. So the query is directly executed in the Windows Explorer. Okay, the query is going to be pasted in the Windows Explorer. It's going to giving the results using the APIs.
Okay, okay. Thank you.
I'm not using any standard data sets or any kind of data sets.
Okay, okay, sir. Okay. Thank you. Is there any question from the other participants? Okay, thank you. Thank you, Dr. D. Bujibabu, sir, for your nice presentation.
Thank you, sir. Thank you.
And I think, Jay, this is the last presentation, or we are having another more?
Sir, one more presentation after this.
Okay, okay.
So our next presenter is Sindhuja, and her paper title is Breast Cancer Classification Model Using Principal Component Analysis and Deep Neural Network. Dear presenter, you can start. And stick to your time, please.
Good afternoon, all. Am I audible?
Yes, and be on time. Thank you.
Yeah, thank you, sir. A few minutes, I'll just share my screen. Good afternoon, all. My topic to present here is breast cancer classification model using the principal component analysis and deep neural network. I'm Sindhuja, Assistant Professor, Rajlakshmi Engineering College from Chennai, India. The agenda here is introduction, key challenges, motivation, objectives, system overview, methodology, results and discussion, and finally conclusion. So the introduction here is based upon the oncology. The oncology, which is the branch of medicine where the researchers will be doing the researches and identify and treats the cancer. So we are having some traditional diagnosis, for example, like CT scanning, MRI, even the normal human screening testing. So some radiological methods are there to diagnose the cancer. And this is a non-communicable disease where the abnormal cell reproduces again, and it will invade the other parts of the body, which will form the cell clusters that can be called as a tumors. The tumors, it may be a benign or it may be a malignant, which is and this non-communicable disease is the deadliest disease in the world of the patients to die. And the recent Globocon statistics, which is the Indian statistics of 2020 India for both the sexes and male, where I can identify that in both the cases, the breast cancer, it is the leading cancer for the female patients, which is causing the death for the females. And the key challenges I identified here is from the cancer registry, and it is revealing that 70 to 80% patients are in the advanced stage of cancer, and most of the people are dying because of the reason is they are predicted. There are, even though there are most conventional traditional methods like machine learning and data mining are there to predict this kind of cancer. Even though most traditional methods are there, the accuracy prediction, it is not up to the level to occurrence of this cancer. And continuing with the challenges, the challenge here, it may be like a cyst, or it may be like a calcification form, whether it may be some age, or it may be some history, race, ethnicity. These are all some of the factors which will which will cause the reason to grow this breast cancer. And the main motivation of this research work is since it is in if most of the people are diagnosed in the very advanced stage, which is causing the death for the cancer patients. And classifying the types of the cancer is very much important for the drug discovery. And also most of the patients are in the advanced stage. The earlier cancer studies classifications have only the limited diagnostic ability. And one more important thing is whenever this breast cancer it is being identified at the early stage means surely the most of the people, female patients, can be treated appropriate with medicines. So this main motivation here is accurate prediction, accurate treatment can be given only with the disease can be predicted at the very early stage, maybe at the stage 1. And even though many technologies are there, it can be proven with new upcoming technologies to predict this kind of breast cancers at the very early stage. And so main thing is when early detection, it means that better outcomes. It means that if the breast cancer is detected early, then there is the 100% 5-year relative survival rate can be assured with this early detection of breast cancer. And the main objective of this work is to detect the breast cancer, which is a life-threatening disease for the female patients at the initial stage. So we are going to predict and assessing the risk factors using the deep learning techniques. And the methodologies used here is, I'm using the breast cancer viscous skin original data set, where it is going to have the 11 classes, including the class final target class, which is a benign class as well as the malignant class. And the class distribution is benign is 458 instances, that is, and malignant is 245 instances, that is 34.5 instances. And the system overview is so initially this data set is given to the data pre-processing, where in deep pre-processing I'm going to check out the missing data and normalize the values. Then feature reduction is being done. Then going to give the pre-processed data to the training data, that is a training to be considered as a training data, which is given to the deep neural network. And finally the it is given to the classification. The second process after the pre-processing is feature extraction. So feature extraction is principal component analysis. So where basically the PCS rule of thumb is 3 rules. One is the test for screen, then second one is the cumulative variance, and third one is the rules established by KCR. So I am going to use the cumulative variance for the for my data set. And the principal component is the basic how it is going to work is the cumulative variance. We are going to find the cumulative variance, where the eigenvalues and eigenvectors plays an important role, and the percentage of the variance is explained for every attributes, and then we are going to determine the number of pieces, that is the number of attributes. And we are going to calculate the kth longest segmented predicted length of the pieces, and we are going to consider about 80% to 100% of the variance here. So here the step 1 of the PCA is I'm going to extract the features using the using PCA. We are going to calculate the eigenvalues, and then we are select based upon the eigenvalue and the cumulative values, the principal components are being selected, and based upon that reduced dimension we can able to get. And step number 2 is based upon the ranked attributes, I'm extracting the which is the attributes which is going to have the highest impact over the target classes. And coming to the classification part, so in classification I'm going to use the deep neural network as my classifier. So here in deep neural network I'm going to set my input layers and the input nodes, where I'll be sending my feature extracted features to the input nodes and passes to the hidden layers. And based upon the learning rate and the bias values, the network will be trained. And I'm going to use the ReLU activation function here, and where I'm at this ReLU activation function, then I'm going to explain and giving my epochs here. Continuing with this classification, I'm going to model my classification rate based on the feeding the test data over the trained network, and by giving the test data for my trained network, so the final outcome can be given by the DNN classifier model. So from that I can able to get the final value, either it is a benign cancer that is benign, or it may be a malignant cancer. So this is how my deep neural networks will be working on. And finally, I'm going to verify the model. The results and discussion coming to this part, they're based upon the PCA at level 6. So this is the principal eigenvalues and the eigenindex for the value 6. And this is what the cumulative variance and the for the PCs. So based upon this eigenvalues, these are all the eigenvalues for each and every attributes, and we are going to select the 5 attributes based upon the ith segmentations, 80% to 100%. So where I have tested parallelly for the screen test as well as for the KG rule. So the number of PCs selected for the screen test and the KG rule is 6 and 8 respectively, whereas the cumulative variance it is 5. So on training accuracy for the cumulative is 97.3 and the testing accuracy is 96.3. Here this is what the model accuracy and the loss. I can prove that the DNN classifier along with this PCA, the training accuracy as well as the testing accuracy is more than the training accuracy, and as well as for the loss, the loss is getting reduced for the testing model. And then, sorry, this is a note. And then the performance comparison of both the systems here is, so these are all the previous existing models which has been given by different authors, where the authors have used Navy-based classifications, then CART using PCA, then SVM model. So I'm proposing here DNA along with the PCA, where I get the accuracy of 98.4 with the model evaluation metrics 80 to 20%. That is 80% for training and 20% is for testing. And the final conclusion I can bring up with this DNN model here is, so a combination of this PCA and deep neural network were utilized to classify the data in the proposed system, and where I can achieve 98.4% in classifying the breast cancer benign and malignant. And inputs are carried and processed across many layers with the many neurons. And in future, this work can be carried out with the different advanced deep learning algorithms can be carried out. And these are all the references I have referred. Thank you. Thank you, sir.
Thank you, ma'am, for your nice presentation. I think we can close the session now with all permissions.
Thank you so much for your nice presentation.
Thank you, sir.
All the present papers are done. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all authors for being a part of this World Conference. I hope this session was informative enough. We on behalf of whole team, thank you for support for this version, and we'll be happy to see you in second version in 2023. All the presenters would be getting their digital certificate through email within 2 working days. And further, all the papers are already forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ISBM. And the last, I thank our session chair, Tanupriya Chaudhary sir, for chairing the session. So there is a little token of appreciation on behalf of ISBM and Global Knowledge Foundation. Thank you, sir, for your valuable time.
Thank you very much. Thank you to you all. Thank you.
At
Due
the
to my
last,
meeting, as of
yes, sir.
now, I have to leave early, as because the session will be closed on near about 3 p.m.
Yes,
Yeah.
sir. At the last, I request all the presenters to turn on their camera for a quick snapshot for the making the memory of this virtual conference.
Sir? Hello?
Yes, sir.
Yeah, it's
Sir,
fine. Jay, you may take the snapshot, please.
Shall I be changing presentation?
Yes, sir, done. Thank you so much, all.
Thank you.
Take care.
Thank you.
Thank you so much.
Thank you, team.
Thank you.